making fun of my language.
Yes, I am.
A mumbler?
It's
That's your language. That's how you talk.
Yes, I want us to speak
Portuguese.
4 languages. Portuguese is not a
What
language.
are the 4 languages?
Portuguese is not a language.
Huh?
That's crazy.
Turkish, Farsi, other, huh? Yes.
All right, so one of the question I want to go over is this one. Square root of 4 minus x. It was t. So this is the question I want to go over. And there's another one I want to go over is f of x equal to sine square of x plus cosine of x. And that they want to find critical number. Yes.
Should you do the absolute value one?
Yeah, we're gonna do absolute value one. What things that f of x equal to 3 minus absolute value x minus 3? Is that right?
Yeah.
And between where?
-1 and 5.
Okay. So I'm gonna start with the one. Like this is 3 question that a little bit more interesting. Now for me, like I want you to take a derivative of this and to see if you can do a derivative correctly. The problem is people don't know how to take a derivative correctly. Separate. I need you to focus on Calc 1 before you fail the next test.
I say next to that, Vincent. Me and Vincent, bro. I literally explained those
I was
last
not
time.
completely through.
And then he left the call.
Yeah, because she wasn't getting. I was already pissed because of Iron, and like she wasn't getting anything either, and I was like, bro, I failed as a teacher. I just quit.
Did Aaron pass the first segment?
Oh yeah.
Second segment?
No, he didn't. You haven't finished.
How many segments?
How many segments are there?
No, how many total segments? Oh, geometry.
Maybe unit. 3.
And you haven't finished second unit?
Huh?
Have you finished second unit yet? First unit?
Or you're on the first unit?
Huh?
You just started the first unit. For segment 2.
Oh, for segment 2. How many segments are there? 2 segments?
2 segments. Each segment is 3 units, and there's a
Arna's unit.
yeah, for honors there's 1 more, but like for him there's 3 more units, and then there's a what is the test you take to pass like graduate? GOC. And there's a GOC review.
POC, yeah.
GOC.
All right, so hopefully you know how to take a derivative of this.
Not gonna graduate.
If you take a derivative of this, you must understand that there is 2 parentheses here. So that's equal to x times 4 minus x to the 1/2 power. If you take a derivative of this, it requires product and chain. So you cannot just do, chain on something or product. You're not doing product or you're not doing the other way around. So if I take a derivative of x, that should be 1. If I take a 4 minus x to the 1/2 power, and it should be plus, the x is alone, and then 1/2 times 4 minus x to the negative 1/2 times -1. Hannah, does that make sense? And the Hannah wasn't the only one that got it wrong. Anybody else got it wrong? The Apple? Okay, Apple, what did you get wrong?
Look at me like
I heard through it though.
I feel like you took like the derivative. I didn't know like we had to like use like the different rules. I only focused on using like the product rule. I didn't apply like chain rule.
Okay, so yes, because anything out of parenthesis other power than 1, it requires chain rule. So if you see this other parenthesis, this is 2 layer, right? First, so there's 2 layer. First layer is this, and second layer is this, right? And then the problem is a lot of people either forgot this negative 1/2 or they forgot a negative 1. I don't know what they forgot, but they forgot one of them, or sometimes they forgot both of them. So now I'm going to factor out the most negative term, so be 4 minus x to the negative 1/2. If you factor out any power, you subtract the power. So the problem is subtract 1/2, subtract negative 1/2, so that will make 4 minus x to the first power, which is nice because that's actually just 1 power that's distributable. So at this case, it's going to be negative 1/2 x. So I here it's going to be 4 minus x to the negative 1/2. And that's going to be 4 minus 3 over 2x. 4 minus 3 over 2x is equal to 0. So 4 equal to 3 over 2x. 8 equal to 3x. X equal to 8 over 3. And that's how you get 8 over 3. And you have to test, because they say x is less than 3 or greater than 3. I forgot. So I'm going to do 3 and 8 over 3. If I plug in 3, I think I'm going to get 1. Oh, I'm going to get 3 is going to be 3. If I plug in a over 3, you had to get a y value. A lot of you guys didn't go in to get y value because what if we ask you absolute maximum y value? So it's going to be 8 over 3 times square root of 4 minus 8 over 3. And I think this one is going to be 8 over 3 square root of 4 over 3. So square root of 4 over square root of 3. So that's equal to 16 over 3 square root of 3. I think 9, sorry. This is the final answer. You have to get this value because you got to go in to verify whether it's true or not. And this is true because 16 root 3 over 9 is that. So not only you have to do homework, you have to check your answers. If you don't check your answer, you don't know if it's right or wrong. The best way to check is using decimals. For me, I think a lot of people start doing things the right way. The right way is you do your homework every day, show up to school with Damien.
Oh, he's
Huh?
traveling right now.
He's traveling? Where?
Out of state. I don't know nowhere.
What?
Yeah, something else.
Oh. Okay, so now you're gonna get to this part. I think this year I had a most issue for us attendance issue. So I think this year we'll have the lowest pass rate I will have ever have. Because a lot of people don't show up to school and you struggle in math, yes.
Is that why you're giving retakes on all the tests?
I didn't give any retake last year.
Yeah, no.
Yeah. And then that's you ask Gabby will be like, what? You guys got retake?
Yeah, she said that it was stupid and unfair. She was mad.
No, the stupid one is you guys, not them. They
Is it
ordered
90
tomorrow.
degrees?
I'm not stupid.
Wait, is it?
Yeah, I don't know what it is. Maybe. I don't know.
Okay, so yeah, it's the truth is like you know, you look at Kaden don't show up, you look at Damien, look at who else?
Vincent.
Vincent not showing up yesterday. Yes, Miranda. What?
I was literally here yesterday.
Because 3 is in the intervals that they say is x is less than 3 or something like that. So you have to test the endpoint. I don't know, it's 2, which 3 here is 3 times square root of 1. So it's 3.
Wait, but yeah, but why did you want me to do?
Because they say x is less than 3 according to the questions.
When they're asking for the critical number, are we looking at the x value or the y value?
The critical number is the c, so the x.
But
If it is asking you absolute maximum value, then it's y value.
so for these questions, we're only looking for the x value.
We're looking for the, if it depends on the prompt of the question. The prompt, if it's asking you absolute maximum value or minimum value, then yeah, that's gonna be the value. If it's asking critical number, for example, this question is asking critical number. So if you take a derivative of x, that's gonna be 2 layers. The problem is people take a derivative sine squared wrong. It's 2 sine of x cosine of x. I don't know, did anybody make mistake on derivative of sine of square of x? You did? What did you do?
Did
2 sine of x?
2 sine of x, yeah.
Yeah, and that's the problem a lot of students, they don't see the chain rule. So I posted another set of homework is for you guys to see the chain rule over there. So that's those two parts. Today's homework is multiple choice, so it's a fairly fast. So I'm a review of all those things. I feel like you guys need to get stronger on derivative. So this one's gonna be 2 sine of x because there's 2 layer. So because you have sine of x and square. So there's 2 layers, so it's gonna be cosine of x. And then minus sine of x here. If you factor out sine of x, that's going to be 2 cosine of x minus 1. Sine of x equal to 0, x equal to pi. And 2 cosine of x minus 1 equal to 0, cosine of x equal to 1 half. X equal to pi over 3 and 5 pi over 3. And this is how you get this one. This one's a harder one. Yes. 16 root 3 over 9. That's because if I plug in. Now for the, I'm going to put in, tell you again, anything to deal with absolute value, Jacob asked this question, is actually a very good question. Anything to deal with absolute value, you might want to write down on your notes. Anything to deal with absolute value, always graph it. And the reason being is, yes, there are formula to take derivative of absolute value, but it's not needed because that's dumb to memorize extra formula. Even this textbook, like, is version 11E. This textbook has no derivative of absolute value, absolutely none. It has all other formula, except there's no derivative of absolute value. And there was a reason why. There was a formula for it. If you look up online, I don't know anybody look up online, take a derivative of absolute value. Yesterday, did anybody do that? Okay. If somebody in first period, there's 2 people did it. I said, no, it's not needed. Anytime graphically understanding is better. Like you look at Sepper. Sepper will tell you yesterday we went over antiderivative question of absolute value. We just look at a graph. We didn't look at the derivative of that. And we are talking about antiderivative, derivative, limits. Every time you graph it first. So if I have this function, 3 minus absolute value x minus 3, basically this is going to go right 3 and upside down. And it's going to go up 3. So it's going to be like this. 1, 2, 3. This shifting to the right. This is reflect across y-axis. Across the y-axis, yes. And this 3 is going to go up. So it's going to be like this. And it's like this. I think it's between -1 to 1, right? So I hear that is a critical point. Why? Because that's derivatives does not exist. So x and y at 3, that's going to give you 3. So this is a critical number. At the end point, it's going to be -1. That's going to be -1. I think another one's 5 is 1. So absolute maximum is this one, and absolute min is this one. So absolute max, or min, sorry, min, and this is absolute max. And so there is no calculation involved because derivative does not exist at the short term. But you have to know how to graph x minus 3, absolute value x minus 3. So if you don't know, cover it up first. Cover this part up first, just focus on x minus 3. That means the absolute value is going to shift right 3. And if you have a negative sign, that's going to shift downward, so it becomes like this. And then it's going to go up 3 units. And that's it. Yes?
What would the graph look like if it was 3 plus absolute?
3 plus x. So that's a good question. So if I have absolute value of x, right, like this. So if you want to plus a 3, it's moving left 3.
Oh, okay.
If it's a minus 3, it's moving right 3. And if I put a negative sign in the front, it's going to flip downwards. It's going to reflect. And if I plus 3, so at this is the same thing as 3 minus, so I can put a 3 here. So it's going to go up 3 units. So that's basically, that's your graph going to go.
Okay.
So today we're going to talk about rules value theorem. Yes. You can plug in endpoint, but there's also critical points, which is the sharp turn.
Yeah. So I just
You can do that if you know where the sharp turn is. But for me, it's a graph it, then you know where the sharp turn is. Any questions? Yes.
Wait, Mr. A, so when it says like -1 to 5, is it any point in between that?
So you have to plug in -1 and 5.
So why would it not be when x equals to 4?
X equal to 4.
Like, because that's not one of the x's that we can put in.
What?
I don't get why. Isn't there like points that are higher on the graph?
No. The highest point is at the critical number at 3. Because that was inverted absolute value graph, and that's highest peak.
When did you?
All right, so Michael rules. Michael Rule, he is a mathematician. He doesn't like calculus, just like most of you guys. So eventually, throughout early part of his life, he really says, "Oh, calculus dumb, it's not needed." And but later part of his life, he says, "Well, I guess I see the point of I see the point of calculus." So Michael Rules is basically come up with a rules theorem. So rules theorem is fairly easy. Rules theorem has 3 conditions. So A, B, C. Okay, Larissa, we'll go over it later. Let me finish this part. So rules theorem is gonna have 3 conditions. The first condition says f of x is continuous. Now pay attention on interval. Is including A, including B. So you cannot have an open circle at the endpoints. If you have open circle at endpoint, rules theorem does not apply. So you must have a 3 condition. This is the first condition. The second condition is f of x is differentiable. A to B. But this is an open circle because endpoint is not differentiable. So you should not take account into the endpoint. So this is close and this is open. So that means not inclusive, not including A and B, because it's not differentiable. Now close is because you have to have a solid dot at endpoint. If it's open circle at endpoint, that's also does not apply rules theorem. C. This one is actually interesting. I put it in different color because other mathematician, the second mathematician after this one, after rules, his name is Lagrange. Lagrange says this one is no longer needed. So it was short Michael rules come up with theorem, and Lagrange kind of modified. He actually got rid of the third condition. But we'll talk about that on Monday. What it says, there's at least one C where f of prime of C is equal to 0. So there's at least one C. Well, why is that? Well, imagine if we have a point. And if I have f of A is equal to f of B. Right? F of A is equal to f of B. Now, imagine that you have a straight line. Well, what's the slope of a straight line? 0. So you can have infinite amount of C. That's the most C that you can have. But most of the time, it's not going to be a straight line. So I'm going to just give you a one situation. So you can have this, right? Guess what? At some point C here, this is f prime of C is equal to 0 because that's a horizontal tangent. Because you can have here, f prime of C is equal to 0. Is that okay? Or you can have more than one. So it could be like this and this. You could have something like this, right? You could have, this is f prime of C equal to 0, and this point is f prime of C is equal to 0. So this is C1 and this is C2. So that's why they say at least one. But it has to be continuous and differentiable. We're going to talk about where is the counterexample. This is not working at those cases, right? Not work at if it's not continuous. Imagine that if I have a graph and have asymptote at, let's just say asymptote at 1, and even though they have the condition here, let's say FA equal to FB, let's say A and B. The problem is I have asymptote. There is nowhere in line where you have a slope is equal to 0. So it has to be continuous first. Now you can also say, this is also another case where not working, is, hey, what happens if you have a cusp? So you have this point and you have this and you have this. Is any part in this graph that has slope equal to 0? No, because they never have horizontal. They actually have vertical tangent here. This f prime of C is undefined, but not 0. Not 0, right? So therefore, rules about it does not apply in those two cases. Now, I'm going to talk about the situation. How do you fulfill? You're going to say this continuous, this function is continuous or differentiable. How do I know the function is not continuous, not differentiable? I'll give you a couple of examples. Any polynomial, and those of you guys don't know what's polynomial, is axn plus bx to the n minus 1 plus cx to the n minus 2. Basically like quadratic, cubic, not square root, but any of those polynomial is always continuous. And sine of x, cosine of x, always continuous and differentiable. So if you see any of those function, it's not issue. The only time that you will see is not continuous, not differentiable, is those following function. One of them is rational, but you gotta be careful. It's not continuous only at 1, not differentiable at 1, but it's continuous everywhere throughout. If I were to say it's from 2 to 5, then you'd be like, yeah, it still apply. It's still okay. Because only not continuous at 1. So if it's 0 to 5, then you're going to say, oh, no, this doesn't work. Does that make sense? Because it will work, let's say, from 2 to 5, but not, let's say, -2 to 5. Why? Because this one's not different. There's 1 over x minus 1. X cannot equal to 1. So it's not, there's an issue there. Another type of function that you might have problem is absolute value x. Again, where the cusp is not differentiable. So x is not differentiable at a cusp, which is at 0, right? You got tan of x, secant of x, cosecant of x, cotan of x. They all have asymptote. So anytime you have equation with asymptotes or sharp turn or cusp, those are things that are not differentiable or not continuous. So those are things that they should not apply. But you gotta check the interval though, because sometimes they can trick you on interval, especially on math competitions. Asymptotes at n, so. And especially vertical. Not a horizontal. Horizontal not an issue. Vertical is an issue. So if you have any of those functions, you have to be careful. So I'm gonna give you a Rolle's value theorem. It will say f of x equal to x4 minus 2x squared, I think. Between -2 to 2, where f prime of c is equal to 0. Yeah. I'm just gonna say, oh yeah, this is polynomial. So all polynomial are continuous and differentiable. So between -2 to 2. Is that okay? Yes. Because this is the interval, so you are gonna say it's from -2 to 2. You're gonna say they are continuous and differentiable. But it's implied and inclusive, yes. Because you're gonna make sure f2 and f-2 is defined. Now, why do they need to define? Because the third condition says f of -2 has to equal to f of 2. Well, f of -2 is going to be -2 to the 4th minus 2 times -2 squared. I think that's equal to 8. F of 2 is equal to -2 to the 2 to the 4th minus 2 times 2 squared. That's equal to 8 as well. So they both equal to 8, so all the conditions fulfill. So then you can go ahead find the value c. Let's see how many c there are. Well, this is really easy because this is simple power rule. So it'll be 4x cubed minus 4x. And you're going to take out 4x, that's going to be x squared minus 1. And it's going to take out 4x, x plus 1, and x minus 1. So how many c there are? 3. So there are 3 c's where Rolle's value theorem apply. And if you graph it, if you graph this function, you want to find out those places. So this is how you check your answer, right? 4x to the cube. Is cube or fourth? Fourth. It's x to the 4th, right?
Yeah.
Minus what?
2x squared.
And you see this, the x value were the c that they have horizontal tangent. So today is very easy. The homework is going to be multiple choice plus that. Not just a review of derivative, and make sure you know how to do review of derivative. Because those questions you cannot learn and dump. The problem is right now is people learn and dump all their life. And that's why when you come to this class, some people don't know how to factor, some people don't know how to do fraction. And that's where it failed. So you can start with homework. That part is the homework and also the other part. So 2 parts. Because today's multiple choice is fairly fast. Were you wearing toga? Are you supposed to wear shoes?
I didn't want to like.
We're supposed to be bare feet because you are like.
He's not supposed to wear a shirt. He's objectifying me.
You should be bare feet, right? That's what Greeks back then. They don't have sandals.
Well, yeah, but I don't think I can get away with that.
You should come with bare feet.
I could. I mean, I have the ability to right now. I just need to get past the bean.
It's okay. It says toga. Back in the Greek, do they wear shoes? I guess when the shoes invented, that's an interesting question.
What is this?
What is the question? What is what? What's the weird number?
Well, good news, Samuel Medina dropped my class.
It's
He did?
okay.
Great.
But I don't see him also. I just want to make sure he's okay. Anybody saw him?
I use 45.
And then
Yeah.
nothing.
He has the ability to tell you what-
Also factor out the most negative power when you simplify. Also, please don't throw food here or outside.
My name's Edward. Beautiful name.
Over there.
Maybe doing that, or is that just easy?
No, it's not even for BC. He just want to do it for fun because I say you cannot do it.
I'll do it, Mr. A. Watch.
Like number
Was
two.
the tutorial good?
For my work to not get deleted, I'm just gonna put this in the corner of the room.
Let's see it. Where we got?
5:30.
Have a good day.
Mr. Ian, guess what? I got my SAT 1380. And your first score is 1390. Don't celebrate yet. Mine's not out.
She's so happy.
I know this morning. I started jumping up and running around my house.
But what's the part?
A 1310. My reading is horrible. My reading
My word!
was so bad. And then I was like, I'm gonna be on time today. Then I realized I have a day schedule. So my bad, Mr. A. But you're so right, bro. Yes, please. Math, I got a 670, but I have a 680 in math. So that's good.
Oh my god. I was like, okay.
Asian parents are not gonna be that good.
I know.
Even if you got perfect scores, like, oh, that's
Yeah, I was like,
how it's supposed to be.
Whoa!
Right, it's on that thing, it's messed up. Did you get the message?
What? Wait for message.
I sent you the homework yesterday. What?
I don't know why it's this.
Vacuum cleaner.
I was wondering where is my mom like drinking yesterday.
Where's my mom? So scared, guys.
Our phone's not working either. He's working.
Yeah, Eli's doing it right. No.
You don't have anything under there? No, hell no.
Eli. Not getting underwear on the bro.
It's real.
Are you doing something today?
Yeah. I'm behind. I gotta go. And go.
Hey, what's up, man? Yo, actually looks like Jesus Christ, bro.
Oh, by the way, Jones said this.
Yes, bro. No one's in there. I can't.
Two separate lights came out to me and said, yo, that Jesus Christ.
They will.
Your name is Jesus too, bro.
She said that in Time TV, every single Friday, they would have a Friday, they put a picture of you. Why not? No, she said you're all
I'm here, but I have to
A lot. I was laughing.
National Muafa, does anybody want to see? Okay, but you have to pay $10. They give you a certificate.
Hi, Mr. Gay. Is it okay if I go to orchestra so we can organize our quartet music for solo and ensemble?
You must go skip it.
I brought you started that okay? Thank you, Mr. Gay.
What? My brother?
You do? Oh, you just don't mind that? Oh, bro, he's not so the guy right now. Straight back to me, Jim, bro. Wrong time to me, bro. Maybe the real reason.
Alright, get your homework out, and we're gonna keep on going to other stuff, and
No, Peter. She will play more.
I don't have my work time. I swear on my life. Can I go get it?
I genuinely
Oh, yeah. I did upset.
I didn't, you know what?
You see, yeah, it's really bad.
Position.
Yeah, so I learned to get online. Not
It's a difference between
Whoa! Oh, I don't think I could get it. No, she doesn't have it. I have no worries.
I did all of them. Kind of 13
I thought it was position acceleration. Wait, so, you know what the, yeah, I mean, like, yeah, it's okay. Let's try that. I'm gonna go there.
It's not solved, bro.
Great, some of them are like,
It's 9:40.
You know what I'm working.
No, it's 9:40. Here you go.
Bro, that's not
if I can't do it,
We can go at like 9:11.